Hey there, I'm Alan Furstenberg,
And I'm Mark Tucker. Welcome to Two Voice Devs.
Two Voice Devs. So this is going to be the second of some things that are a little different, watching us actually experimenting with LangChain. And I think we had an interesting take on how we got into this one.
Yeah, so this one was about Voiceflow and kind of some of the work that they were doing to include AI and LLMs into their product, and they had a sample, and it was just kind of us jumping in and trying to understand what we could from the code that they supplied.
Right. So this is basically a kind of walkthrough that they provided, and both of us, having not looked over the article very much beforehand, went through it live while we were recording things. So it's interesting. I hope you'll find it interesting anyway.
All right, so we're starting off at this Voiceflow blog post about how to integrate OpenAI GPT using your knowledge base. The idea is that there's going to be some sort of an API that has a couple of different endpoints. One of them is /question, one of them is /parser, and you're going to be able to crawl your website, and this is going to be like a frequently asked questions bot. That's kind of my understanding of what this is showing.
Okay.
So it's talking about a number of different technologies, and some of these technologies are listed here: OpenAI GPT, LangChain, this HNSW Live, and then Cheerio. Go ahead.
No.
Do you have any questions?
So well, nothing. I think it's kind of important to understand what each of these are. So OpenAI is used to generate the answers to the questions, and it's not clear to me exactly, is it using it? I guess we'll see what part of it that it's using to do that. LangChain, as we're discussing elsewhere, is just good at kind of piecing other pieces together.
Yeah, it's talking about here that it's specifically using it like a number of utilities just kind of to do natural language processing. It's going to use this Cheerio loader to kind of load documents based on web pages that are crawled from, let's assuming like your corporate website, and you wanted to have this frequently asked questions bot. Then it's going to split it into smaller chunks using this splitter, and then it's going to use this OpenAI embeddings. And I think that's the part that's going to allow the question to be asked specifically about the content that was crawled. So and then this last part is this vector DB QA. I'm assuming that's question and answers chain.
Right. So an embedding, if I got this correctly, is kind of the equivalent of the document converted into vectors. And OpenAI provides an API that does that.
Okay.
However, you need to break it up into smaller chunks, and that, I guess, is what LangChain's built-in recursive character text splitter does, is break it up into chunks that are small enough to feed into OpenAI, who will turn it into vectors that it returns back, that I guess it stores in the vector database, which I guess is the HQ whatever.
Yeah, that's what that seems like, for me too. So there's two endpoints, and this is specifically a Voiceflow example. So the diagram here, kind of at the top, is showing how do you do the flow out and dialogue flow, and this represents the two different APIs, the two different post calls that are possible, and kind of the flow, asking like, sure, what's your question, and this going through like, please give me the documents that you want me to add, and kind of keeps cursing back to how can I help you, and then you ask another question, and I think it's supposed to be able to answer based on what's been crawled. So that's the kind of the understanding at that point. So this parser endpoint is going to, and kind of behind the scenes, and we'll look at some code. It's using an Express JS to create, in essence, a web server that has this /parser and /question endpoints. But
okay, so with that one,
one's going to be for crawling documents, and the other one's actually going to be asking the questions.
Okay, so the parser one, you send it a URL, and it goes and uses LangChain to, well, uses the LangChain stuff to fetch it, break it up into chunks, feed it to OpenAI to turn it into vectors and save it into the vector database.
So what this sounds like is that I'm assuming that this endpoint can't be like hosted on AWS Lambda. I'm assuming this is some website that's hosted like on EC2 or something that's around, so that I don't know. We'll see, but I don't know where this database is actually stored. Is it going to be like a file system database? Is that where is this going to be stored?
That I don't know. That's a good question, because I don't know that there are vector databases that are APIs, that are vector database as a service.
Okay, yeah, maybe that's it then.
Maybe it is. I don't know if that's one of them, because I could go look it up, I suppose.
Okay. Well, yeah, we'll see what we can glean from the code.
Okay, and the question endpoint takes the user's question and generates an answer using GPT in the context from the vector database.
Yes.
So there are a couple of ways that you can do this. One way, I think, is that for some of the GPT models, you can provide embeddings, which you get out of the vector database, and it applies them. But that's not all of the GPT models. It's not even the good GPT models. So I guess we need to see more about what's going on with that.
Yeah, well, yeah, we'll see. So the caveat here is that we have not yet watched this video. This is us just kind of reading through the explanation and now looking at code to see what we can grok from it. So there'll be some assumptions. Some of this stuff is obviously new, and we're just going to take what we've learned over the years and just kind of see what we can understand from the code and kind of make some assumptions, which could be right or wrong at this point in time. So we could turn out and be completely wrong in certain parts, but this is us just kind of grappling just by looking at the code.
Before you do that, what was the database name again?
It was HNSW Lib.
Right. HNSW Lib. Okay, there it is.
Oh, we got some libs versus libs. And so at the bottom here is this link to the GitHub repository. So that's kind of where we're looking now, is this Voiceflow demo repo. And there's really not a lot to it. This is giving Alan a little bit of time to look up stuff. But if you look at it, there is really only this app.js file and this package. So the only real code is, let's see how much we've got here, is the 178 lines of code in this file is kind of the whole thing.
And as we've talked about before, that's actually kind of one of the nifty things about LangChain, is that it lets you do some things in really, really terse code.
Yeah. So just going to at the top, kind of the first place to check out here in this file. So we've got Express.js, so that's going to allow us to create a web server, so we can kind of specify this post endpoint with the slash question or the slash. Well, I can't remember what it was called now. So that's going to help us define that. HTTP is going to help us do HTTP communication. Some crypto library we'll figure out here. It looks like immediately it's being used to turn a secret into a digest. So we'll have to figure that part out. And then references to HNSWlib is from LangChain. OpenAI embeddings is from LangChain. Prompt template, LangChain. OpenAI, LangChain. So this is our LLMS. We have different chains. I guess there's some different files, but I guess there's already some. Would a chain already be kind of like a group of primitives that are already packaged together to do a certain task? And so is that what the LLM chain is and the vector DB QA chain is kind of grouping some things together?
Basically, so it basically is taking small atomic things like creating a template or tokenizing something, and you're normally going to take the output of one, feed it into the input of the next one,
right? And
that's what a chain is, I think.
Okay. So yeah, so pipeline a chain, yeah.
Right.
Okay. And then it looks like there's a whole. It's leaning heavily on LangChain. All of these different imports are
Yeah, that
things
totally does not surprise me.
and then it looks like it's doing file systems. So so maybe the hunch of this being stored on the file system of the web server might be true.
So I found out, well, looking through this, I found out what HSNW is.
Okay.
Sorry, HNSW. It is a library that implements approximate nearest neighbor search based on hierarchical, navigable, small world graphs. So those vector graphs that we have are hierarchical, navigable, small world graphs.
Okay.
Got that?
It would help if I had a visual of it, because that seems to lock things in better for me, but we'll just go with it. And so is this in essence the store, the thing that that we're crawling with Cheerio is going to be stored in HNSW store, because it's got vector stores here.
Yes.
So that means it seems like it's a database of some sort. It could be in memory, it could be file based, it could be a REST,
right.
SAS.
So I think that what a vector is, the best way to kind of understand it is if you understand, multidimensional attributes. So like when they talk about how GPT-4 has 4 billion parameters or whatever number it is, I can't remember anymore. And, they say it's, more parameters than this other one, which only has 2 billion parameters. Basically, the way it works is it reads in data, and as it reads in each token, it assigns a value between 0 and 1 for each of those parameters for that token. So, for example, if a token is blue, somewhere in that list of 4 billion parameters, there may be a parameter that represents this is about somebody's mood, and there might
a blue mood versus
a cheery mood.
Okay, all right.
And somewhere else in there might be a parameter that is associated with color. And
this
somewhere
guy is
else,
blue.
right?
Okay.
And somewhere else in there may be a parameter associated with the moon.
Okay.
So it might assign a value saying, the value of blue when it talks about colors is very high, 0.8, 0.9, I don't know. I'm making this up. Moods might be somewhat less, maybe 6 or 7. And maybe for a moon, it might be even less, 0.3 or 0.4. Yeah. And all of this gets stored in the vector database. And what I am kind of guessing is that what the hierarchical navigable small world graph does is, based on a word, finds it in this database, and based on a string of words, starts navigating through these words to see which ones are closest in relation to other ones that have similar parameters.
So I don't know if this is an exact analogy or not, but it seems like kind of like your text completion, where you're starting to type a Google search and it's like, oh, you've typed these words, and so the next word that it's going to suggest to you is this. Is that kind of the same concept?
That is exactly the concept.
Okay, all right.
I mean, it has been, large language models have been described as autocomplete on steroids.
All right, I hadn't heard that. That's cool.
So what a vector store is this database that has taken our document, broken it up into tokens, and stored for some number of parameters for each token that into the database in such a way that makes it easy to navigate through it based on the parameters. I don't know if people can see. I'm making weird hand gestures trying to relate this.
So that's interesting. What I'm wondering about is how big the store is. So let's say that you've got a website that has 10 pages, and I don't know, 2,000, 3,000 characters or words, I don't know, whatever on each page, how big does this store go? So like one call to this endpoint where we're wanting to add a URL, like add a web page to it, how much space would this take up on disk or in memory? I'm wondering how big these vector stores get for each item that's added to the store.
I haven't the vaguest idea. I'll be honest.
So that's a good, yeah. So
And-
that's kind of what I'm thinking. I'm like, okay, cool. There's something's being stored, but how big is it?
Right.
In order to do what it needs to do to be predictive and try to figure out what's being said. Does that turn out to be a lot of space that is taken up to do that?
I imagine it would. I think this particular library though is an in-memory library.
Okay.
So it's meant to index, it's probably not going to index more than a few pages.
Okay. All right. Do we want to continue on with the code and kind of just see what we can gather from that?
Yeah, sure.
All right. So
I'm also to be fair, I'm also at the same time trying to understand more about what HNSWlib is.
Okay, that's cool. This part is .env is being able to pass in environment variables into your code. And so in this case, it's showing that we're grabbing an environment variable called secret and creating a hash, a digest from a hash. And we're not sure where that's going to come up later, but look for the word key later on and see where that's being used. This is setting up our Express.js application and saying what it's going to use. It's going to go ahead and do URL encoding, and it's going to accept JSON. So probably the post body formats is going to be JSON. That's what it says actually in the comment. That's cool. So we're defining one post endpoint for API/question. And if we go down here farther, there's probably going to be another. Yep, here's an API post for API.parser. So the parser part happens first, and then the question part. So maybe we'll actually tackle that in that order. And then there's a function for cleaning the file path and cleaning text. And this actually creates the server and hosts it on whatever port you pass an environment variable. And this is going to log out to the console that this API is running. So you could run this locally and you'd be able to see this. Okay, so let's take these sub functions one by one without really even getting into too much detail. So it's going to use some regex that matches all alphanumeric and hyphens and replace all non-matching characters with an empty string. So I think it's just stripping out things that aren't alphanumeric. Oh, I'm having a hard time saying alphanumeric today. And hyphens. Okay, so that's just kind of cleaning up the file path so that we don't get any weird things that you can't use in a file path, which also makes me then think that this is going to be stored to a file on the web server. And then cleaning up text is going to match all new lines at the beginning of a string and replace those with an empty string. So we're stripping out new line characters. So that's what those things do. All right, so let's go up to this parser part. So remember when this is an example of the string that we would send to parser. We would say, this is the URL that we want you to crawl. And so inside here, we grab the the request body, what's being posted, and we pull out the URL and the API key, which were those two parameters right there, URL and API key. So that's cool. And what are we doing?
So basically, the first three lines are: we get the URL, we create a loader that knows about this URL.
Right.
We then load the URL, getting an HTML document, presumably.
Okay, so this actually goes to the website and scrapes the document, whatever the content, and we get the content of the HTML page in doc.
Right.
Right. So then we're going to new up one of these splitters. We're going to chunk things up by 2,500 characters. with chunk overlap. I'm not sure what those are, but we're basically splitting up this whole document into smaller text strings, right?
Well, we're not doing anything yet. We're setting up something that will be
Yes.
able to do it though. That basically says we need chunks of no more than 2,500 tokens, and we want some overlap in those chunks to, I guess, make it easier to figure out where each piece fits in.
Okay, because so that would take care of like sentences being chopped off in the middle, right? Things like that, right?
I think this code has a bug in it on line 111.
Interesting, because it's just saying splitter as opposed to text splitter, because there is no text splitter up here.
I don't think so.
Yeah, I don't see any text splitter.
So I think that's a bug.
Yeah, that's right. So this is where we're using that cipher key. So we have the document output here. So this is actually the actual document output.
I'm guessing this is so that we can have multiple versions running on the same server.
Oh,
for different
I see.
people having different API keys.
Oh, okay. So like if you've got, assume at Voiceflow, each project has a different API key. You could use the same server and have multiple projects use. And so it's going to create a directory for each project, and that's where that's going to store the vectors.
Yes.
That's what it seems like to me. Good tip.
Yeah.
Good call.
As we see, down at line 124, it tries to load it from the directory.
Okay, so that's where everything's getting stored. It's got this new OpenAI embeddings. So somehow it's going to convert, or that's a parameter into this vector store. So we get back the vector store in the right format that OpenAI needs for embedding.
Well, I don't think we're actually I think what vector store is at this point is just a reference to the vector store.
Oh, okay. That would make sense.
And saying, you'll load any existing one from this directory, and we have a reference to the OpenAI embeddings object in case we need to generate another to process more embeddings.
Oh, okay.
I think.
All right, that sounds reasonable. So here we're actually reading the file from that directory. So there's a single JSON file called docstore.json.
Load that in and parse it.
Load it in and parse it. So now we've got the database, and then we're going to check if metadata with the same store already exists. All right, so check to see if it exists. If it exists, if the source already exists, then we say that it already exists. If the source doesn't exist, then this is where we're going to add that document that we scraped to the vector store. So this is actually, at this point in time, going to add the document to the vector store, and then this catch is part of the bigger, trying to do the actually loading of the store.
Right. If it didn't load it in because it didn't exist, go create a new one to begin with.
Okay. So at this point we should have a vector store, because we're going to save the vector store to directory. So at this point we do have a vector store saved on the file system of the web server. So
a couple of things are important here. I think line 142 and 146, basically it's saying we've created the vector store by default. When it loads it in, needs to know about the OpenAI embedding, so that when you load a document, basically when on line 142, when we add a document, what it will automatically do is it loads in that document, it sends it to OpenAI to create the set of vectors, gets the set of vectors back, and stores it in the vector store.
Okay.
So that it does a whole bunch of things under the hood there.
Yeah.
And that's kind of LangChain's modus operandi, is doing magic for you.
Yes. Excellent.
And then either because we added a document or we created a new vector store from a document, on line 150, we then save it to the directory.
Yeah. So this is us updating. So this is every time this API is calling, it's going to load the vector store from the file system if it exists. It's going to add a document to it. Or it's going to process the document, add the vectors to the store, and then save the store all over again to that same single file under that directory.
Well, save it to the directory. We don't, how it saves it to the directory is an implementation detail that is hidden from us.
Oh, that is true. But it's interesting because here, though, that we're loading. Okay, yeah. So we're loading the directory. We're not loading a specific file.
Again, when we do the load, we specify a directory for it.
Yeah. So the vector store itself knows about the directory, but this one does know about the file.
That may be the data. I mean, it may just be one file in there.
Yeah, that's interesting. Well, we'd have to investigate that farther.
Yeah.
And then we get some sort of either a 200 success, you know, that this document's been added or that it was already there, or a 500 error because we couldn't process it. So that's us, you know, hitting this endpoint of the server that's you know, stateful, I guess, in nature because it's got the persistent data store. So then over time you can add additional documents. So this could be something where you have 10 pages on your website and you're like, oh, I've added another page. I'm going to call this endpoint with the new page, and it's going to crawl that. And now that's also possible to search.
So an interesting element here, kind of, this looks very similar to a lot of the examples that they give, that LangChain gives already. The notable part is, and the reason why it does, because they all kind of function the same. It's on line 111. Basically, what that kind of says, or you know, the up at line 103, 104 combined with line 111. Basically, what it's doing is it's loading in a web page. You can load in anything as long as you build your own loader. That loads in and creates these documents. So there are, you know, LangChain provides loaders for reading in from a Google Doc, reading in from a PDF file, reading in from a CSV file, reading in from a spreadsheet, from a LaTeX file, from, you know, there are all sorts of document readers that already exist. So using any of those to get the data into your vector store is possible.
Yeah. And very easily, because it's basically separated the document loading to the text splitting to the, you know, vector store part. So it's you know, and just putting those together, you know, and there's lots of stuff that happens, you know, behind the scenes in each of those different chains potentially. It could be one step, it could be 10 steps, you know, whatever. It's just a nice little package that you get to use.
Right.
And once again, you can do this in Node.js or in Python, right?
Right.
All right.
So we looked at the parser. Let's go look at what a search looks like. So
when a question comes in, we're going to have two different things passed in on the body, in the JSON body, the question or the API key. I'm assuming the same type of thing. This is probably going to help us find the directory that we're going to use to search the right data vector store, right? So this is the question that somebody asked, like in this example here, the question was, what are the types of use cases where, this was just a generic thing, but you could ask like, what's the return policy for blah, 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 for, you know, shoes or, right? So whatever this is the user's question. Now it might be different from the prompt that we're going to send to GPT, but
you'll see in a second what happens there. I have a funny feeling.
Yeah. All right. So I think this encryption thing is going to be basically the same thing. So here, OpenAI, that's going to be a library from LangChain, right?
It is a LangChain library that's built on top of OpenAI's API.
Okay, and so we're using GPT version 3.5 Turbo.
Right, which is, it's the one that ChatGPT was originally based on.
All right, so if you're using ChatGPT and you can see that you can use 3.5 legacy, 3.5, or if you pay for it, you can use 4. Right. So at this point in time, this example is using 3.5.
Right.
Okay. So here we're looking up the directory. Here's the vector store. We're loading the
We're loading our vector
store from the
store,
directory.
or
All
we are creating a vector store object. It's not entirely clear if it actually loads that in or not.
Okay, fair enough. So here we're going to use this prompt layer open AI. I'm not sure what a prompt layer is, but here is this prompt layer API key. So this is something I'm assuming that OpenAI needs to call their API. Why do we have this OpenAI LLM here, and we have, I'm confused here, because now we have the same constant variable LLM here,
right?
And it's saying new prompt layer OpenAI. I'm confused at that because this is 3.5 turbo. It also references 3.5 turbo 0301. Concurrency values are different, 10 and 15. Cache is true, temperature, and then so I'm not sure. I don't know if this is a bug also in the code, if it should only just be one or the other. So yeah, because I'm not sure what happens with this. I don't see LLM being used anywhere before it's used again or defined again. So that probably would even be an error. So that's
okay. So let me I think from a quick search, let me try to explain this.
Okay.
From what I think it is, the first one shouldn't be there.
Okay.
The second one, it makes sense to have the second one there. And what it uses a service called prompt layer. And prompt layer, as I understand it, logs and debugs your calls to OpenAI so that you can see exactly what was sent and maybe how it didn't work. Because under the hood, a lot of prompting, there are prompts that go on that you don't necessarily see how everything got put together. So in order to see how it gets put together, you use this other service and it relays things through that service, and that's prompt layer.
Oh, okay. All right, but in the end, we're this is us configuring which version of GPT that we're using to do the query.
Right. So there's a couple of things in there. So it includes your API key for prompt layer. It includes PL tags let you tag things inside prompt layer so you can search for them later, I think.
Okay. That would make sense. So because all these other things are happening and they're all kind of in the same logs, you can then filter out that based on the things that just have to do with this particular
right.
Right.
Model name is above. What we see here is the GPT 3.5 turbo one, or you can nail it to a specific version. Otherwise, you get whatever the latest version they've released is. That's what that's showing there.
All right, so then this is using an existing chain called a vector DBQA chain. So this is saying you've got a vector database that's set up for question and answer. And so it's a chain, meaning there's lots of different, multiple steps behind the scenes that's being, hidden from us, or let's at least collected together so it's easier for us to use. And so it's going to load this chain from the LLM that we've got set up and the store that we created earlier. So then it's doing a chain.call search. And the query, the search is the thing that we search for, right? That was the variable up here.
I thought that was question.
I don't know. So it was question that it pulled out of here. So that's another question with this code, is what this value search is coming from. So I think like 2 different versions of this code somehow got commingled into this file, and now we're trying to figure out what's what from that. But So I'm not exactly sure what that chain is doing here compared to, because here's an else, but there is no if that goes to that else.
Really?
Yeah.
Oops.
If you actually look at it, it matches up
It matches a
bracket
try.
wise up to that try. So there's something amiss in the code. So this is fun. Trying to figure out what the intention
Well, but I mean,
was.
at least the comment says we don't have a vector store yet, so we'll just use a template.
That's
And
interesting.
that's interesting.
And this is, and so there would be some sort of a, yeah, so I don't know exactly how that works, but this one is like saying if we don't have a vector store, then we're going to say, hey, we're telling ChatGPT, you're an AI assistant, and you're going to try to answer this question, and then this is where it's going to splat in the question that you passed in the API. And if you don't know the answer, just say, I'm not sure. Don't try to make it up. There you go. Don't try to make up an answer. So this is our prompt to GPT to say, answer this question, but be as factual as you can. And so then we're going to use a new prompt template, passing it this template. Input variable would be the question that actually got passed. It's going to do a new LLM chain. So this is going to use the LLM. So this would be like a typical way that you would talk to ChatGPT would be to say, here, ChatGPT, here's the prompt that I want you to answer. And so then it's going to get the chain back, and then you can call the chain, which is actually going to go and get the response back.
Right.
And then you can return that response back.
So what this is you've set up your LLM chain with what LLM you're going to use and the prompt template that you've built up above. And then you call the chain with actually the values that are going to be filled into the template.
Yeah. So like this matches right here, this JSON response.json clean text. Here's the response.json. So the missing code here would be actually, or maybe this is the code to say, hey, go call this ChatGPT, but using this vector store to find your answers.
Well, so that's it. I'm not entirely, well, yes.
So there is some missing code or some mismatched variable names. So I'm not sure exactly, but this seems to be the part where it's saying search your vector store, and this is the part that says just ask generally ChatGPT to answer the question with some minimal instruction to not make things up.
Yeah. So
and that's it.
Yeah, I mean, you can see that a lot of it is pretty standard and straightforward code, just that got put into an API call so that you can access it from Voiceflow.
Yeah. What's interesting to me, or like a question that I've got here, is this concurrency. So I'm not sure if this is a parameter that's being used by LangChain, or if this is somehow the number of concurrent calls that you can make to ChatGPT from the API that you've got. So I'm not exactly sure what that concurrency value or where things are being cached. So I'm assuming that's ChatGPT because this temperature value.
The temperature value I recognize.
Yeah, is that the higher the number? Like if it's 1 or closer to 1, then it's more random, as opposed to if it's 0, it's.
I believe so, yes.
All right. Well, that was kind of fun, just trying to figure that out. There does seem like there's some problems from the code. I'm anxious now to go back and watch the video myself and see how close we were in our joint effort at trying to grok this code with
right.
kind of only limited experience. Surprising. Well, maybe not so surprisingly, it does lean heavily on LangChain. Go ahead, Alan.
Oh, it's not surprising to me at all. I think what's interesting is to kind of, say the voice connection here is that this was done as the webhooks for Voiceflow.
Yeah.
So it's kind of assuming that, there's nothing about Voiceflow specifically in what we're looking at right now.
Yeah.
It's kind of, Voiceflow is handling one set of magic, and then this is handling a different set of magic.
Yeah. And because you can call APIs from Voiceflow, then you can plug in ChatGPT. So you could technically take this server and reuse it, whether you're using Jovo, whether it's a chatbot, whether it's a voice assistant. You could reuse this.
Right.
It's just doing text processing to answer a question based on documents or default if it doesn't know that.
Exactly. And I think we're going to be seeing that in, we saw that with some of the stuff that Noble and I talked about, for example, is, a lot of it is, and in fact, it's stuff that we've talked about many times before, is, it's just a matter of putting the right pieces together, and then fitting them in. And I think what's going to be interesting is, as we aren't just saying, well, we're slapping a voice interface on top of this, it's seeing how does it fit into a voice conversation as a whole. Well, I think where it starts to, where we'll start to get interesting.
Yeah, like how do you gather the prompt? Is, like what's the question that's being asked is like, what question do you have? Is that the voice assistant or the chat bot, whatever, is that the question it's going to be asking you? And then how do you answer that? Do you how do you capture what you want to say? If it's by voice, how's that different than if it's just typing it, the text of the question into your keyboard and
stuff. As I was showing you, the other week when I started playing with LangChain. So and then we're going to start having to deal with issues like, okay, what is the response time on this?
Yeah.
Because it's cool to go search your own documents, but one of the great things about search indexes used to be that they were incredibly fast. GPT is notoriously slow. So how do we fit that into a voice response? And I think we're gonna have to talk about that one another time.
Yeah, and does it get to a point where it's possible to run, some version of GPT on like a client, or so it's not an API call. So part of it's actually, or like maybe this whole thing could actually all be done client side, right?
Well, I think there's going to be some of it is that maybe your vector store will live locally.
Yeah.
And you need the compute power to create, to turn a document into, to create the embeddings for a document.
Yeah, that could be very interesting. Or could it be done in a way where this vector store of things that you care about follows you around, and so then now it's made available to whatever assistant you're talking to, and now it can.
That'll be that's an interesting notion. Yes.
Yeah.
So okay, so more experimenting with LangChain, and
yeah, this turned out to be a lot more LangChain involved than I first thought. Right, I was like, oh, okay, this is ChatGPT, but it is using that, but it is using a whole bunch of libraries from LangChain, which makes me. Then sometimes I just do this, makes me want to go and just read through all the different chains that are currently available. From LangChain to better understand what they are, because I'm like, oh, this is a whole toolbox I could use for other things.
It is, but trying to read through it is I don't get it yet. I haven't wrapped my head around it yet, and I've been reading through the documentation for weeks now. Noble's been helping me, which is why I was glad to have him on. But I'm still trying to wrap my head around everything. I think the other interesting bit here is that we're not, I guess we need to read more about it, is just how much ChatGPT itself was part of the equation. I think one of the things I need to read and understand more of is how much was GPT actually part of the equation here. We can see that OpenAI's calls were used to do the embeddings. But how much was GPT 3.5 Turbo involved in generating the result? and how much was our vector database used in generating the result? And
Oh, that's interesting. Yeah.
I don't have the answer to that yet.
Yeah, there's got to be some, natural language processing that's happening to take the text string and turn that into something that that can call the vector store. And I'm assuming that's what GPT is doing, but I'm not sure. I don't know enough about, like you say, about either of those
Yeah. So
to know how that works behind the scenes.
So more to read and play with.
Well, it was cool. Thanks. That was kind of fun just to kind of cold start, look through that code and try to figure out what it was
Yeah,
doing.
that was interesting.
Well, so that's what we were able to figure out. Sometimes it's just fun to hang out with somebody and walk through code and talk about it and kind of talk your way through it to see if you could understand it. And I had a lot of fun doing that with you, Alan. So thank you for that.
No, thank you for that. Because, I think one of the elements about it that I really liked was that, we were trying stuff and going, I don't know what this means. Do you know what this means? Well, I don't know. Let's, figure it out. And, one or the other of us would go off and try to untangle what this was supposed to be. So that was fun. And led to a lot of stuff that, I know I want us to explore some more in the future. I hopefully people who are watching this are exploring. I'd love to hear people's feedback. I really want people to tell us what what they're getting out of this and what they're learning in this field, because there's so much to learn.
Yeah, there is. It's kind of fun, but can be overwhelming at times.
Yeah. So love to hear what you have to say. Twitter, LinkedIn, comments below. You can find us on Alexa, Slack. We're all around. Leave us a message and we'll talk about it another time on Two Voice Devs.
On Two Voice Devs. Thank you, Alan.
Thank you, Mark.